All right, today we're going to talk about a piece of technology that totally changed the game for anyone writing code in .NET. It's the story of Roslyn, and it's all about how the compiler went from this lockdown thing to a wide-open platform. So, let's get into it.
You know that feeling, right? You're typing away, and your editor just gets you. It's suggesting the rest of the line, it's spotting your typos as you make them, it's even offering to fix them for you. Well, that little bit of magic, that IntelliSense, it's not really magic. It's actually a direct result of the revolution that we're talking about today.
So, to really get why Roslyn was such a big deal, we have to rewind a bit. For the longest time, compilers were basically these mysterious black boxes. You'd feed your source code into one end, some secret, complex stuff would happen inside, and out the other end would pop machine code. That was it. End of story.
Yeah, this whole black box model was just how things were done. It was a one-way street, your code went in, and the compiled result came out. But for anyone who wanted to build smarter tools for developers, this was a massive, massive roadblock.
See, a traditional compiler does one thing. It translates. And to do that, it has to build up this incredibly rich, detailed understanding of your code, the structure, the meaning, all the relationships between different parts. But here's the crazy part. As soon as the translation was done, all of that priceless knowledge just got thrown away. It was locked inside the box, totally inaccessible. So what's the big deal? Well, if you wanted to build something like a linter or a refactoring tool, or even a basic find-all references feature, you couldn't just ask the compiler for help. Oh no! You had to write your own parser, your own semantic analyzer. You basically had to reinvent the compiler's entire brain from scratch every single time. And that, as you can imagine, made innovation painfully slow.
But then, Microsoft decided to do something pretty radical. They decided it was time to crack that black box wide open. The project was codenamed Roslyn, and its mission was nothing less than to completely reinvent what a compiler could be.
And this is the key takeaway. Roslyn is not just a compiler. It's the .NET compiler platform. Sure, it still compiles your C# and Visual Basic code, but the game changer is that it also exposes every single ounce of its understanding through a set of powerful APIs. The black box officially became a toolbox.
Now, this didn't happen overnight. The codename first popped up way back in 2010. And a little fun fact for you, it's named after Roslyn, Washington, which is the town where the TV show Northern Exposure was filmed. After a few years of previews, they made it open source in 2014, which was a huge deal at the time, before it finally launched with Visual Studio 2015.
So how on earth did they pull this off? Well, it meant completely rethinking what a compiler even is. It wasn't about just drilling a peephole into the side of the box. It was about redesigning the whole thing from the ground up to be more like an open, public library instead of a locked room.
I mean, the shift was just fundamental. We went from an opaque translator to an open platform. Instead of just getting compiled code out, we now get access to rich APIs. All that internal knowledge the compiler has, what Microsoft beautifully calls its wealth of information, is now shared with any tool that wants it. It was truly designed for tool building, right from the start.
And Roslyn gives you this access to a few different layers. At the very bottom, you've got the compiler APIs. This gives you the raw stuff, the syntax trees, the semantic models. Think of it as direct access to the compiler's brain. Then you've got the workspace APIs, which are perfect for IDEs to manage whole projects and solutions. And finally, at the top, the feature APIs give you ready-made pieces to build powerful things like refactorings and code fixes super easily.
Okay, so the box is open. What does that actually mean for us developers day to day? What can we build now? This is where things get really, really cool. First up, analyzers. These are basically little helpers that live inside your editor, watching your code as you type. They use the Roslyn APIs to understand what you're doing and can flag potential issues, style problems, or just bad practices, all in real time.
And what's an analyzer without its trusty sidekick, the code fix, right? When an analyzer finds a problem, a code fix can offer you one or more ways to fix it automatically. It's that little light bulb icon that pops up, ready to clean up the mess with just one click.
And this, right here, is where the magic happens. All of a sudden, this whole ecosystem of tools just exploded into existence. Teams can now write analyzers to enforce their own coding rules. Library authors can ship analyzers with their packages to teach you the right way to use their code. The entire community can build and share tools that make everyone's code better. And it doesn't even stop there. The platform also powers something even more advanced called source generators. These are wild. They're components that run during compilation and can actually write new source code for you on the fly. This lets developers get rid of tons of boilerplate and generate super optimized code automatically.
So, let's zoom out. What's the big picture? The impact of Roslyn wasn't just some small improvement. It was a seismic shift in how we fundamentally interact with our own code. When you boil it all down, Roslyn's legacy is one of transformation. It took that old-school compiler, that one-way, opaque black box we talked about, and completely reimagined it. And it turned it into a living, breathing, open platform for innovation. This single change basically democratized code analysis and unleashed a wave of creativity that makes all of us better, more productive developers every single day.
You know, this quote from Microsoft really just nails it. The mission was to open the boxes and let everyone share in that wealth of information that compilers have always had. And in doing that, they empowered a whole community to build the future of developer tooling.
It's such a powerful lesson, isn't it? The value of an open platform versus a closed system. And it kind of leaves you wondering, what's the next big black box in our industry that's just sitting there, waiting for someone to come along, open it up, and share what's inside?